Now this question is on the topic of speed of reaction, and we are looking at how different factors can affect the type of graphs that are obtained. Alright, so this the reaction that we're looking at is between marble, which is calcium carbonate, with hydrochloric acid, which will produce your salt, carbon dioxide, and water. Alright, so we have already learned in the syllabus that if a reaction produces a gas, there are two ways to measure the speed of reaction. First way is to measure the volume of gas produced with time. Alright, the other one is to measure the mass loss with time. Alright, why? Because the gas is going to escape from the reaction mixture, so the overall mass of your reaction mixture will decrease with time. So in this question, we are looking at the second method for measuring the speed of reaction. And so the graph that is obtained is shown in the question. Now for a graph like that, remember there are usually 2 points to look out for. There are 3, but the third one doesn't apply over here. So the 2 points would be the gradient at the start, which is also known as the initial rate. Alright, and the second point to look out for is the final mass after the reaction is complete, meaning the gradient has reached 0. Okay, so if we compare experiment 1 and experiment 2, so they are asking you which one could give you the graph 2, which factor would produce a graph as shown for graph 2. Alright, so let's compare 1 and 2. The first difference is this, that the gradient is steeper. Steeper means that in experiment 2, the speed is higher. Alright, so the factor must result in an increase in the speed of the reaction. Okay, next thing to look out for is to notice that the final mass in reaction 2 is lower than reaction 1. What does that mean? It means that you have more CO2 produced. Okay, so the factor that or the change in the experiment must also lead to more reaction happening, which results in more carbon dioxide that are being produced. Alright, with that in mind, let's look at the 3 changes. Change 1, double the mass of marble chips but in smaller pieces. Alright, so if we consider the factor, if you have smaller pieces, yes, your speed will increase. Okay, so it seems to satisfy one of the condition. But if you double the mass of the marble chip, will it result in more reaction? For that, we need to go back to the question, right, to find out which one is limiting and which one is in excess. Over here, they tell you that your marble chips are in excess. So if I use more of an excess reagent, will I get more products? Answer is no. Alright, so 1 is wrong. Okay, change number 2, the same volume of a more concentrated hydrochloric acid. Now, when you use a more concentrated solution, obviously your speed will be higher. So we have one of the conditions that's being met. Now, will there be more reaction when we have the same volume of a more concentrated hydrochloric acid? If you were to compute number of moles, you will find that the number of moles of hydrochloric acid will be larger as well. And since hydrochloric acid is the limiting reagent, there will be increased reaction as well. Alright, meaning there will be more CO2 produced, there will be a greater extent in the mass loss. So 2 is correct. For change number 3, the reaction was carried out at a higher temperature. At a higher temperature, will the speed of reaction increase? Answer is yes. Alright, but at a higher temperature, will there be more reaction? Answer is no. Alright, changing the temperature will not change the amount of carbon dioxide produced. So the correct answer is 2 only.